Hello and welcome back. We now discuss question number 2 from exercise 6.1. The question says, in a cattle breeding farm, it is prescribed that the food ration for one animal must contain 14, 22 and 1 unit of nutrients A, B and C respectively. Two kinds of fodder are available. Each unit weight of these two contain the following amounts of the three nutrients. So this data has been tabulated. So we have the fodder, that is fodder 1, fodder 2 and the nutrients A, B, C and the respective ingredients in each unit. Next, the cost of fodder 1 is rupees 3 per unit and that of fodder 2 is rupees 2 per unit. Formulate the LPP to minimize the cost. Now, in order to minimize the cost, one must know the quantity of fodder one has to buy. Okay, and that has not been given. So we assume the quantities of fodders as X and Y respectively. So we first define the non-negative constraints, that is X and Y. So we have, let X be the quantity of fodder 1. Let X be the quantity of fodder 1 and Y be the quantity of fodder 2. Okay. Now we can simply bring down this table. Now before that, the quantities cannot be negative, right? So we could have this condition, X and Y both are greater than equal to 0. So these are our non-negative constraints. Now let us copy the table. So we have fodder versus the nutrient. So we have fodder, fodder 1, fodder 2 and here we have the nutrients. So we can just put it over here. So here we have the nutrients. Okay, now there are three nutrients over here. So it's A, B and C. Now the quantity of fodder 1 we have taken as X units and fodder 2 as Y units. And each unit contains 2, 2, 1 units of A, B and C. So here you have 2, 2, 1. This is for fodder 1. And for fodder 2 we have 1, 3, 1. The quantity is 1, 3, 1. Now the condition given here is the animal must have 14, 22 and 1 unit of nutrients A, B and C. So this is the minimum requirement, 14, 22 and 1. So that's the minimum requirement. So the minimum requirement is 14, 22 and 1. Now we could get our inequations very easily. So let us write down the inequations. Now for nutrient A, okay, now if we consider nutrient A, the quantity of A from fodder 1 in X units would be 2X, right? Because each unit of fodder 1 has 2 units of nutrient A. So X units will have 2X units of nutrient A. And 1 unit of fodder 2 has 1 unit of nutrient A. So therefore Y units will have 1 into Y, that is Y. So total quantity of nutrient A is 2X plus Y. Now this total must be at least 14. So we put the sign greater than or equal to 14. Similarly for nutrient B, total quantity of nutrient B from fodder 1 and fodder 2 will be 2 times X plus 3 times Y. And this quantity must be at least 22. So minimum requirement is 22, that is 22 and above. And likewise for nutrient C, the total nutrient C quantity would be 1 into X, that is X, plus 1 into Y, that is Y, and this total must be greater than or equal to 1. So we have all the inequalities in place. Now let us just complete this table. So if we just draw this table over here, okay, let's complete the table properly. So let's see what we get over here. Then this is fodder 1, then fodder 2, the minimum requirements, and lastly we have the inequations. Now we go to the other aspect of the sum. They have given the cost of fodder 1 is rupees 3 per unit and that of fodder 2 is rupees 2 per unit. So therefore the total cost would be, now 1 unit of fodder 1 costs us rupees 3. So X units would cost 3X. And 1 unit of fodder 2 is costing 2 rupees per unit. So Y units will cost us 2Y. So this is the total cost, 3X plus 2Y. So we have written down all the conditions and therefore we could say the LPP is, now cost has to be minimum, so we say minimize, the objective function is Z, which is equal to 3X plus 2Y subject to, now there are certain restrictions, right? So we note down those restrictions over here under the heading subject to. Now these are the 3 restrictions for nutrients A, B and C. So the first restriction is 2X plus Y must be greater than equal to 14. Second, 2X plus 3Y must be greater than or equal to 22. And the last one is X plus Y must be greater than equal to 1. Also not to forget the non-negative constraints, that is X and Y greater than equal to 0. So this is the required LPP.